In the last exercise regarding exploring exponential models, we looked at the bird population dying off by half. In this situation, we're going to be looking at the value of a 3D printer worth $120,000 and how it will depreciate by 40% each year. So let us take some time to remind ourselves of setting up a situation where we must first try to define the variables. In this case, we're going to let the letter t equal the number of years and let the letter p equal the value of the 3D printer. We're going to organize our work like we have done in the past by setting up a table. We'll have years and we'll have the value of the 3D printer. So at year 0, we're going to have the value of the 3D printer be worth $120,000. After 1 year, the value of the 3D printer is going to depreciate by 40%. What that means is that in the following year, the value of the 3D printer is going to be worth $120,000 times 0.6, which would give us a value of $72,000. At 2 years, the price of the 3D printer is going to be worth 60% of what it was worth at year 1. That is to say, we will again multiply 120,000 times 0.6. This number represents the value of the 3D printer after 1 year. We now want to find 60% of that value. So we will again multiply this number by 0.6. If we are to simplify this expression, we will then come up with 120,000 times 0.6 squared, which will give us a value of $43,200. At year 3, we will continue to do the same step. That is 120,000 times 0.6 times 0.6 times 0.6. What this is doing is this is allowing us to find 60% of the value of the 3D printer from year 2. When we simplify this expression, we will then get 120,000 times 0.6 to the third power, which will give us a value of $25,920. As with previous lessons, we continue to see a pattern of repetition. In this case, we continue to see the original number being multiplied by the same number continuously. Let us remind ourselves of what the original price of the 3D printer was. In this case, the original price was $120,000. In the course of 1 year, it retained 60% of its value because it was depreciating by 40%. After 2 years, it retained 60% again. So 120,000 times 0.6 is the same as 72,000. The same thing can be said with year 3. 43,200 can be represented as 120,000 times 0.6 times 0.6. In that same pattern of repetition, we see how the number of years represented on our table at the left can be seen as the same numbers represented with the exponents. In this case, we can have an exponent of 1 on top of 0.6, which will lead us to associate the number of years with the number in the exponent, the number 2 with the number 2 here with this exponent, and the number 3 in this exponent. Now that we've taken the time to look at the pattern, we can begin to generalize this situation. Let us look now at what the formula would look like if we had t years elapse. That is to say, we would then multiply 120,000 times 0.6 to the t power. This generalization of the pattern allows us to represent the value of the 3D printer as P equals 120,000 times 0.6 to the t power, where t is the number of years that elapse and p is the value of the 3D printer after a certain number of years. Now that we have spent some time exploring this situation and generalizing the pattern that we discovered, we can then now use this same formula to determine the value of the 3D printer in 5 years. Let us go ahead and use our equation again, which was P equals 120,000 times 0.6. And in this case, since our time is 5 years, we will raise 0.6 to the 5th power. This will go ahead and give us a calculation of approximately $9,331 with 20 cents. The value of the 3D printer will be $9,331 with 20 cents in 5 years. What that means that in the course of 5 years, the value of the 3D printer lost approximately $110,668 with 80 cents. This situation allowed us to look at the representation of the number of years and the exponents associated with numbers as we did in previous lessons. Like previous lessons, we continue to see a pattern of repetition, which we are then able to discover and generalize a formula for a given situation.